Class we are going to study the sensitivity analysis for any optimization problem. Okay, so what is the basic concept for the sensitivity analysis here? So suppose I consider कि a maximization problem is given to us. Okay, so some c1 x1 plus c2 x2. Okay, subject to some certain constraints. We are just considering a linear programming problem. Okay, suppose we have already solved it and obtained the optimal solution, the optimal value of the z, the extrema, that means for which x1 x2 it is occurring, everything we have solved. So once this problem is solved, suppose after solving it we come to know that there is certain change in the constraint or any of the parameters related to the problem is going to change. Okay, actually what happens when we solve any optimization problem is actually related to some physical problem, some practical problem. Okay, so suppose we solved it, we did everything and the solution is already known to us. All of a sudden we have to incorporate some changes into that problem itself. Maybe suppose we are just considering the carpenter's problem which we discussed earlier. Suppose the constraint of the labor is changing, or the constraint of the amount of lumber present is changing, or the profit that the carpenter can make per table or per whatever their material they are making is changing. So changes can occur in infinitely many ways. Now the question is, once the changes is occurring after we have solved the whole problem, entire problem, then once this changes we have to consider what is the considerable effect that this changes is going to make on the, say suppose optimal solution, or the maximum value of the optimal solution, or the extrema at which the optimum solution is obtained, and likewise. So in nutshell we are just going to say that once we have solved the problem, all of a sudden if we just try to incorporate certain changes in the constants or any related parameter to the problem, then what can be the changes, or how we are going to study the changes in different respect of the problem itself. Okay, so here actually what we will do here now, we won't go into a general therapy or a general treatment of this problem, because actually it is an enormous one. If you want to give a general strategy, it is just not going to be covered in a single part of the syllabus. Okay, so what we are just going to do, we have just introduced the concept, and now we are just going to see a few instances or discuss a few instances related to this sensitivity analysis. Okay, with the main motive key, through the instances which we will discuss, you will get the idea that okay, in this type or in this way rather, the changes are affecting the solution of the problem. Okay, so for that we will just consider the carpenter's problem which we have already done before. Okay, and let us just see what the two instances are going to affect it. Okay, so now let us go back to the PDF material itself. Okay, so suppose this was the objective function for the carpenter's problem. Okay, what was the carpenter's problem? He was making some sort of tables and another one, a bookshelf, I think, a bookcase. Okay, so and there was some net profit for each table and each bookcase, and he has as a given amount of resource material in the form of lumber, that is the material of which he will make this goods, and also he has some labor. Okay, so with that we already solved his problem of maximizing the profit subjected to the constraints. Okay, and the objective function in that case was this one. If you recall back, this was the objective function 25x1 plus 30x2. Okay, so here x1 was the number of bookcases and table, and x2 was the number of bookcase. Okay, and the profit per bookcase is $30 and the profit per table was $25. Okay, so this was the ultimate thing we already discussed, and the optimal solution came out to be, the maximum value of the z came out to be 750 with respect to all the constraints which are provided. Okay, now we already discussed before what are the level curves for this optimal solution. What was the level curves? Suppose this one was say suppose z equals to some fixed value we to take, and then as it is a maximization problem, so we are going on drawing parallel lines, that means shifting this line parallelly, how, just as to make the perpendicular distance from the origin increase. Okay, but we cannot go on increasing enormously because we have to respect the constraints which are provided. So by respecting all the constraints, 750 came out to be the answer as far as I remember. Okay, so whatever, it is not our main concern what was the result which has come there. So what we are now going to do, first you see, they are considering the slope of this line 25x1 plus 30x. What is the slope of this line? Minus 5/6. Okay, and what they are doing here, they are asking the question, what is the effect of changing the value of the profit for each table? Okay, so what actually we are studying here? We are studying this specific instance, sensitivity of the optimal solution to changes in the coefficients of the objective function. Okay, so coefficients of the objective function means here the objective function is this one. Okay, so the coefficients now are changing means what are the coefficients? 25 and 30 are the coefficients, and x1, x2 is coming from solving, that is finding out the extrema, that is the maxima. If we find out, then x1, x2 correspond to that maxima for which the max profit is maximized. And what are the coefficients? x1's coefficient 25 and x2's coefficient 30. So 25 and 30 are the two coefficients occurring in the objective function. So what we are going to study here, suppose we are going to change any of these two coefficients. For the most simplest picture we are considering, any one of the two coefficients is changed. How will it affect the solutions? That means optimal solution, obviously. That is the maximum value of z. How will it be affected? So that is the thing we are just considering here. Okay. So with this motive, we are doing this one. Okay, what is the effect of changing the value of the profit for each table? So we have considered, okay, we will change the profit for each table. That means we are going to change this 25. This 25 now will be replaced by some certain value, so C. Okay. So let us see how they are doing it. And we eventually make only tables giving the extreme point of 24 tables and 0 bookcases instead of current mix of 12 tables and 15 bookcases. Achha, current means, if you just recall back for this part of the lecture, you have to please be aware, or please just have a look at the last lecture where we just solved all this Carpenter's problem, so that you have everything in mind. 12 and 15 was the optimal, that means the maxima which was coming, for which the maximum value was obtained. Okay, so 12 means x1 12 and x2 was 15. Okay, so let us just see the figure. It will be better to analyze here. This is the level curves, as I said. This one was the optimal. Okay, and there were two constants in the problem other than the positivity constant, that x1 positive and x2 positive. If you leave aside those two constants, two other constants were there. One was the lumbar constant, that means the material constant, and another was the labor constant. Okay, constant 1 and constant 2. Okay, and this C here represents the optimal solution. Okay, that means the maxima actually, optima or the maxima here actually. Okay, so what we are trying to do here, you see this dotted line which is passing to C is actually what? The objective function. Okay, so initially what we are doing, this was a shifting in the objective function. We go on shifting and we have to stop at this line, restricting or just respecting all the constants. Okay, and this was one of the optimal. Okay, so corresponding to this line, I am drawing this line now. So what is actually our function now? Our function is C1 x1 plus 30 x2. As I said, we are changing the profit each table. Okay, so the profit each table was actually 25. We solved the entire problem taking profit to be 25 here, 25. But now, as I said, I will change it. Okay, so we're changing what change? What amount of change I am going to make? That is, I am making some general thing. General thing means what? I am not putting any single value. I am putting a parameter which is going to vary. How long it will vary? That is what we are going to analyze. Okay, so C1 is a, you may know, just say is a symbol representing the parameter of change. Okay, so C1 is the profit part table now. Okay, Achha. Now you see, if I consider this line now, what is the slope of this line? It is minus C1 by 30. So initially you see slope of each of this line was minus 5 by 6. This one, all these are parallel lines. So minus 5 by 6 was the slope. Now what I am doing? I am incorporating the change. That means now my profit line, you may say these are the profit lines. This is the profit line, this is the profit line. Each and everything you draw parallel to it are profit lines. Okay, out of which this is the maximum profit. That's a separate issue. But all of these profit lines was having the slope minus 5 by 6. But now due to the change which we have made here, the profit line is not of the slope minus 5 by 6 always. What is the slope of the profit line now? It is minus C1 by 30, as I am getting from here. If you put into y equal to mx plus c, obviously you know how to find out the slope. Okay, that is a trivial issue here. So minus C1 by 30. Okay. Now you see, as I said, C1 was a variable here. It's a parameter. It's going to vary. Okay. As we vary C1, the slope of the level curve of the objective function changes. Quite obviously, you see, this was initially what we are doing, right? But now we are not doing that thing. what we are doing instead, we are just considering first. So suppose we have considered the 2 points here, the constants, this one constant, this another constant, sorry, on this one again I have taken the same thing, this another constant. Okay, they have intersected at this point, this was the maxima. Okay, now what I am doing here, instead of taking only one slope which was actually given, okay, what we are actually doing here, we are varying the slope of the objective function line. Okay, so for that thing, what actually is happening here, just better to draw it more properly. So we are just considering, or rather concentrating on the change in this objective function line. So I'm just trying to draw the lines corresponding to the change. Okay, so this is objective function line initially. Okay, 25x1 plus 30x2 750 according to my figure, this violet color line. Now what it is going to happen, it is going to change. How it can go to change? It can go to change by changing the slope, because the slope is now dependent on this C1 parameter. Okay, so it can go like this, it can move like this. Say I suppose start with the line, it can rotate in anti-clockwise direction, or it can rotate in clockwise direction. Okay, so this violet color line, the profit line, can rotate in this direction or can rotate in this direction. Okay, so now you see, if I am just considering the constants are the same, I have not changed the constants. So whatever change you are incorporating, you are just changing only with respect to the profit per table. Nothing else is changing, right? So if nothing else is changing, I have to respect all those things. So what I am just doing, this dotted colored line is the profit line. Okay, obviously, but it is not going to rotate just, you know, this 360 degree, it is not going to rotate. It is going to rotate in between these two lines. Okay, so if we impose that thing, what will happen? The slope of this line, the slope of this dotted line is becoming restricted. Okay, here in the extreme clockwise, anti-clockwise rotation, it can go up to this line. This is a constant one line, it had up to this line it can go. It can go on tilting like this. Ultimately it will coincide along this. If it rotates anti-clockwise direction, just in the same case, if it rotates in clockwise direction, maximum it can coincide along this line, that is along constant 2. So just respecting these two constants, this C1 value gets restricted. What is the slope of this constant? The slope of this constant is given by the slope of this straight line. So what is the slope of this straight line? Minus 5 by 4. Okay, so one is minus 5 by 4. Okay, and another one, the slope of this straight line is also putting some constant. What is the slope of this straight line? It is minus 2 by 3. Okay, so minus 2 by 3. So minus 5 by 4 is actually lesser than minus 2 by 3. So my C1 slope should be restricting between these two. Should be restricting between these two means what? It has to be greater than minus 5 by 4. It has to be less than minus 2 by 3. Okay, so that is the thing they are explaining here. Achha, one thing let me just mention here, ki what we are respecting here, we are considering ki 1215 is our maxima. We are not changing it. As I said, ki whenever you study analysis, this sensitivity analysis, that means whenever you are going to study the change, one thing must be kept in mind. What are the fixed things? What are the fixed concepts, or what are the fixed parameters we are maintaining? That is sure, or that is the first thing we have to choose. For example, we are maintaining the thing ki okay, the maxima will not change. That means it was 1215 for the original sum. Even after you just modify the problem, it should remain at 1215 only. Then you just study the rest of the changes. You are not going to change the 1215 maxima thing. Okay, that's why, as I am keeping this one fixed, that's why the profit line is forced to pass through this point C. Otherwise, if I just do not put this restriction, okay, once you incorporate the changes, let the maxima vary. If the maxima vary, it can go anywhere. So in that case, the profit line, this dotted line, is not restricted to pass through the point C. It can pass through any point, provided all these two constants are supported. Okay, it can pass to this point also, it can pass to this point also. Not this point, my mistake, because it is not supporting this shaded color region was a feasible region. So it can pass to this point or pass to this point. But we are not allowing that to do. Why? Because we are keeping the thing fixed, ki the maxima remains fixed here. It cannot change. So with that restriction, again the constants are not changing. So what is the only thing that can change? The value of the optimum, the value of the maximum, the value of z can change only. Okay, so that is the thing they are saying here. So and every change is going to come in terms of this C1 parameter here. Okay, so this C1 parameter again, as we are restricting this 1215 not to change, the constant not to change, the C1 gets restricted itself. Okay, and how is it restricted? It is restricted to lie between minus 5/4 to minus 2/3. Okay, so that is what they are actually explaining here. Okay, so here this case the extreme point remains optimal as long as the slope of the objective function is less than minus 2/3 but greater than minus 5/4. See, as I am restricting this remains the optimum. That means this remains the maxima as long as this minus 2/3 and minus 5/4 thing is restricted. Okay, so this rotation thing is explained here. You rotate the level curve of the objective function clockwise, what will happen? If it rotates clockwise, it can maximum coincide up to this line, and if it rotates anti-clockwise, it can coincide up to this line. Now if you leave this, you can also rotate further also, here also or here also, but in that case this will be getting just hampered. In that case the extremal optimal point is going to change in that case. Okay, so we are not going to see in those cases. So here once I consider this thing, what is going to happen? See, this is the constant which is imposed. The slope of the objective function, once we consider C1 as the profit per table, and the constants on the slope of the objective function, as it has to abide by the maximum point to be 1215 and the constants to be C1 C2 as before. So these are the thing which is coming. Okay, so that is what they are saying. The range of values for which the current extreme point remains optimal is given by this inequality. So ultimately on simplification you are getting this C1 must vary between 20 to 37.5. Okay, so how can we interpret the result? The interpretation comes like this. Key, that means what I am trying to do? I am trying to interpret the result in terms of the physical problem. So what is the problem here? The problem is for the carpenter to maximize his profit. As I am now changing the profit per table, so obviously what the profit which he was making initially $750 which is not going to come here, is definitely going to change. Okay, but one thing he has kept fixed, he will make 12 tables only and 15, right, 12 15, so 15 bookcases. This is going to give him the maximum. This is he has kept fixed. So he has changed the profit per table, he has changed and kept the profit per bookcase the same. Okay, acha. So that's what they are saying. Interpreting the result, if the profit per table exceeds 37.5, profit per table means what? C1 was the profit per table. If it exceeds 37.5, what will happen? The carpenter should produce only tables, that is 24 tables. Where from I am getting this thing? He should produce only tables. We are getting this idea from this curve or from this figure. You see, if he is going to change, that is he is going to go beyond 37.5. okay, where from 37.5 is coming? Let us see. 37.5 is coming from this part, that means from 2/3 part. So from this constant here, from this constant 2/3 constant means here this one constant 1. Okay, so constant 1 means this line. So if it is going to change, go beyond this line 24.0, then what will happen? Then he has to change the number of bookcases or the number of tables he is making. That means in that case this optimal solution part will be hampered. It will change because this restriction is coming only because of the fact that we are restricting this 12-15 thing there. That's why this is coming. Now if I say I won't be abiding by this thing, then what will happen? Obviously the maxima will change. Maxima will change means what? The number of tables he is making or the number of bookcases he is making is going to change definitely. Okay, so that is they are interpreting in that way. If the profit per table exceeds 37.5, the carpenter should produce only tables, that is 24 tables. That means in that case his maxima is going to be given by this point 24 0,24. Okay, in this case this is going to come here. Okay, and similarly if C1 is between 20 and 37.5, he should produce a mix of 12 bookcases and 15 tables. Okay, that means x1 will be 12 in that case and x2 will be 15 in that case. Okay, and as we change c1 over the range 20 to 37.5, the value of the objective function changes even though the location of the extreme point does not. Quite obviously, here you are saying what? Your objective function is c1 x1 plus 25 x2 or 30 x2. Okay, so what is happening? If you are just going to vary this c1 and fixing the extrema to be at 12, 15, that means c1 into 12 plus c2 x2 30 into 15. Okay, so 30 into 15, okay, but what about c1 into 12? c1 is changing, so obviously z is changing. Okay, so how much it is a change? Whatever change c1 is encountering, the change in z is 12 times that change, because 12 is multiplied here. Okay, so that is what they are saying here. Of course, as we change c1 over the range 37.5, that is this range, if you are going to vary, then what will happen? The value of the objective function changes even though the location of the extreme point does not. Obviously, that means the extrema remains just 12, 15 only, but the value of the objective function changes because he is making 12 tables. That is what here. The objective function changes by a factor of 12 times the change in c1. Okay, so what we are just getting here, this is the entire figure we are just getting here. This is 24.240. Okay, this was the x1. The x1 is the number of tables only. Achha, one thing I just said there wrong, that x1, this one, let me just go there. Okay, this is not 24 is not the thing, it is 24.0. So this thing they are actually meaning here. Ki if you allow your this slope line to go beyond this, okay, then what will happen? To go beyond this, then what will happen? It will ultimately 24.0 will be your extrema or maxima in that case. That means in that case he will be only making tables to make the profit, no bookcases. 0 means no bookcase. Okay, and if he is going to fix this 12, 15 only, that is sure to make 12 tables and 15 bookcases, then definitely this is the range of c1's variation, and in that case his objective function's value is sure to change and is changing by a factor of 12 into c1. That is, whatever c1 is changing, so suppose c1 is 0.5, then the total change in objective function is 12 into 0.5, like that. Okay, so this is the thing that is coming. And now let us focus on the extreme 2, that is equality part. If c1 is equal to 20 or c1 is equal to 37.5, what is going to happen in that case? Okay, then note that at the limit c1 equal to 20, there are two extreme points. Achha, one thing let me just mention here, the two extreme points not cb but cd. Okay, and for 37.5 it is cb. Okay, so what they're actually saying, let me just finish this line, then I will say there is a typo here. So for c equal to 20, there are two extreme points for which the same value of the objective function is occurring. That means alternate optima or alternate maxima in this case exist. Okay, when we are changing the problem, if you just recall back, in this problem there was no alternative solution. Only the unique solution was given by c 12, 15. Okay, but now as I am changing by bringing this c1 inside as whatever is set till now, then what will happen? If c1 is, suppose I am giving the value c1 equals to 20, then obviously the objective function, that is the maximum profit, will come at two alternate solution or two alternative extrema. Okay, one will be provided by the c itself, that means the original one. Another one here in this case for 20 it will be d. Okay, that means let us go back into this figure. This will be this point, and again for 37 c1 to be 37.5, it will be given by c. The one optima will be, or one maxima will be c, another maxima will be b. Okay, so why they are saying that you just can simply check by putting the values only. Okay, by putting the values only you can just check it ki how they are saying ki these are going to be your maxima, and this is going to be your alternate maxima. Okay, so for example, what is our objective function here? Our objective function is this one, c1 x1 plus 30 x2. So now suppose if you consider the point c. Okay, so c means 12, x1 is 12 and 30 15, and say suppose I am considering first the value c1 equals to 20, that is I am considering the leftmost extremity, okay, from that restriction. So 20 x1 plus 15x2, right? Sorry, 13x2, 30x2. Okay, so now if I considering the C point, what I am going to get? 20 into 12 plus 30 into 15, that means you are going to get here 240 plus 450, that means 690, right? 690 is the value of Z max. Now you see again, if you consider the point D, okay, what is it? 0.23. Okay, so for 0.23, what is the value coming here? 0.23 means here only again you will put, so 20 into 0, because x1 is 0, plus 30 into 23, that means again 690. So see, the same value of Z max. Okay, but the point, that is the extrema, here this is the maxima 12-15 point, here this is the maxima 12-15 point. When I am getting these two alternate maxima, when I am considering the extreme case, C1 is assuming the value 20, that is the profit part table is $20. Okay, now let us next consider the other extreme point, that means the extreme point of 37.5. Okay, so for 37.5, again the same thing. If you are considering 37.5 now, so here you are going to get this one here only. So 37.5 x1 plus 30 x2. Now again at 12-15, if you just calculate, you have to calculate 37.5 into 12 plus 30 into 15, that means you will be getting some sort of 900. I checked once, it will be coming some 900, right? Okay, and another one will be what? Here this point, the point of B, that is 24.0, then 37.5 into 24. Here also you will get the same value. You just check on your own. As far as I remember, it will be coming like 900. In here also, here also. So the Z max is the same value here and same value here. So for C and B, you are getting the same value of the maximum profit. Okay, whenever we are considering the rightmost extremity of the C1 parameter. Okay, so this is the analysis we are completing here. Okay, see, if C1 is taking any value between 20 and 37.5, not touching these two, then your optimal value is going to change via a factor of 12 C1, and the extrema is going to remain at 12-15. Okay, and what else? So he is going to make a combination of 12 tables and 15 bookcases. Okay, his optimal value is going to change, that is profit function is going to change. Now if he goes beyond this 37.5, then obviously he will make the maximum profit by making 24 tables. That means only tables, that means 24.0 in that case will be the maxima. Okay, and now if he is making below 20 tables, profit per table is below 20, that means if he is going beyond this region, then also in that case the optimal solution will be given by 0,23. Okay, and within inside it is going to vary, as I said. On this side what is going to happen we said, and on this side also we said. Okay, and within this, when the extrema, that means these two extreme conditions we are reaching for 20 and 37.5, in that case alternative optimal solution is coming. Okay, so see, in the entire value, possible value of C1, okay, beyond 20, from 20 to 37.5, beyond 37.5, and again at 20 at 37.5, so everything is analyzed. So the whole analysis becomes complete here. Beyond 20, what will the carpenter do? That is clear. Beyond 37.5, what will be the carpenter do? That is clear. Within this range, that is also clear. At 20 and at 37.5, that is also clear. Okay, so the entire analysis ends here whenever we are just changing the profit part table in the problem which was done before. Okay, so let us stop here. In the next instance we will discuss this one, the change in the amount of resource available.